All right, we have this question, problem 8. Um, so we have to determine all functions that satisfy that equation. So the way I'll solve it at first is um, we are still working on methods of contradiction, argument by contradiction. So I don't know how to make this statement contradictory, but let's like maybe find possible functions that can satisfy the equation. So the first step is I'll go for the simplest step. What if x and y are the same thing? That's the simplest step. So we just write x is equals to y, and if x is equals to y, then it means that f of x should be equals to f of y. Let's call this a. All right. Let's call this f of y. Let's call this b. So this is the output. So if we write the whole equation, we have um a times b plus a times b again is equals to a plus a times f of a squared plus a squared. All right, so let's just simplify. So we have 2ab is equals to 2a times f of 2a squared. All right, so the only way the left hand side can be equal, let's simplify the equation first. So let's just cancel this out, and now we are left with b is equals to f of 2a squared. All right, so what this is trying to tell us that, remember, we have f of x is equals f of y is equals to a number, a constant b, and we're also getting another function, this, and it's also equals to this constant b. So we can assume that this equation holds true for constant value. So like, let's say our f of x, the function f of x is equals to constant k. So no matter the input of x, with x squared plus y squared, x cubed minus z cubed, we always get a k as our answer. So this should be the equation for it. This should be the equation, f of x equals to k. This x is f of x. F of x equals to k. So this is one of the functions that we are looking for. Now the question is, are there other functions? So let's test something. In this one, we assumed a was positive. F of x equals to k is positive. So what if f of x is equals to a negative number? Let's see, would that satisfy the function? Let's see whether it will satisfy. I actually don't know. All right, so we see is equals to minus. So now we have a times minus b plus a times minus b is equals to 2a f of x squared plus y squared. All right, so if you have let's just simplify. We have minus 2ab is equals to 2a f of x squared plus y squared, and let's just cancel out sometimes. That means minus b is equals f of x squared plus y squared. So if we have this here, we are getting this also. So it works regardless of whether b is positive or negative. Yeah, it talks whether b is positive or negative. So uh the equation still stands. F of x is equals to k. So now we've worked with constant function. Now let's see if it works with non-constant function, either linear or um quadratic or quartic function or logarithmic functions. Let's see what it's going to work with. Let's see if there's another function that exists. So if we are saying there's another function that exists that is not a constant function, let's assume f of oh my god f of x. Let me use a different color for x. Let's assume f of x is equals to a, and f of now instead of saying a, let's assume f of x equals f of a. Oh my god, that is a different color. F of a, and so I don't want to use f of x now. I want to use another letter entirely. That's why I'm just doing this. If not, we can just use um f of x and f of y, f of b. Then we are saying if it's a non-constant function, it means that f of x should can be less than or greater than b, but it should not be equals to b if it's a non-constant function. So we are going to see f of a. This is writing f of a instead of f of x. F of a is less than, strictly less than, f of b. Alright, and if you have f of a strictly less than f of b, then let's like implement what we have here with the left hand side. Sorry, with the left hand side here, I can't really zoom because if I zoom it's going to look a bit blurry, so you guys just have to manage. Sorry for that. So if I implementing what we've written down now into the equation, we should have um a times f of y, sorry, not f of y, f of b, plus b times f of a. All right, and hmm, hmm, what can we say about this? Well, we can say that this equation is less than f of a, and at the same time is greater than f of a, at the same time less than f of b, because if we just have f of a, but now we have f of a times something plus something else, it means that it's obviously greater than f of a. But it being less than f of b, okay, sorry, I told you I'm just solving this from scratch. I just okay, I just thought of something. What if, like, since it's like we are multiplying by a and b, let's um imagine we are multiplying by a and b for this inequality right here. So if you're imagining that we are multiplied by a and b, we have a plus b times f of a is less than a plus b times f of b. Then if we are like comparing this, we are comparing this to this, and we want to see where it fits in this inequality, we can, let's expand the the inequality at the bottom first to actually know what we are doing. So it's a times f of a. I changed the color again, that was not intentional. Is less than a times f of b. All right, so now if we are doing some comparison, if you want to compare the gray line to the inequality at the bottom, let's compare it to the left hand side. So let's compare it to here. All right, so if you are comparing, let's rewrite everything again. Not rewriting it, I'm just going to copy paste. I did not know I cut that. Copy paste. This is too long, but yeah. So if you are, oh my god, I'm supposed to only copy the left hand side. If you are copying sorry, if you are comparing the left hand side to the up gray line, we can see this section is, sorry, this section here is equal. So this is the only part we compare, this place here. But we can see that this place here is greater than this place here. I'm going to tick it. It's greater than this place here because we have a times a, but we remember that f of b is greater than f of a. So since f of b is greater than f of a, it means that this this expression in this gray line has to be greater than the left hand side of the inequality. So, but let's do the same comparison with the right hand side of the inequality. I'll soon have to end this video. Ctrl C, Ctrl V. Alright, if we are doing the same comparison, we can see that this place is exactly the same thing. So this is the part you are comparing, the right, but b and b is multiplying something. So what we are comparing is just the functions itself, and we can see that this place is greater than this place. This place is greater because f of b is greater than f of a. Remember from our first statement, this statement here, f of b is greater than f of a. So if you want to fit that expression into the inequality, we are going to see that I'm coming. I am not ready to write that whole expression again. I am not ready to write that whole expression again. So we can safely assume this with certainty, and so this is the inequality we have. I have to end the video now because of I want to make it less than 15 minutes. We'll continue later proving whether there are other functions or whether the constant function is the only function.